Hello and welcome to the Quick Start video tutorial for VisualCAM 2014 brought to you by Mexsoft. Today we'll be discussing the Turn module. Let's begin by launching the VisualCAM-TURN module. From the main menu, select VisualCAM and then Turn from the drop-down menu. Docked on the left you will see the Machining browser and under it the Machining Objects browser. Let's load the part model for this tutorial. From the main menu, select File and then Open. Find the part file named Turn Quick Start Tutorial located in the Quick Start folder and then select Open. From the View toolbar on the left, select the ISO view icon. We will perform the following basic steps in machining this part. First, we'll define the machine and the post processor to use. Then, we'll define the part and stock geometry, material, and work 0. Then we'll create and select a tool to use for machining. We'll create the machining operations, including the feeds, speeds, the clearance geometry, and other cutting parameters. Then we'll generate the toolpaths, simulate the toolpaths, post-process the toolpaths, and then generate shop documentation. Let's start by defining the machine to use for this job. From the Program tab, select Lathe to display the dialog. Set Maximum RPM to 10,000. Pick OK and notice that the machine lathe now appears under Machining Job in the Machining browser. Next, we'll define the Post processor. From the Program tab, select Post to display the dialog. For the current post processor, select FNUC from the list of available posts. Then set the posted file extension to NC. Other file extensions are available depending on your machine requirements. Pick OK and notice that the post type now appears under the Machining Job in the Machining browser. Now we'll define the part geometry. From the Program tab, select Part to display the dialog. Pick the Select Surfaces button. The dialog is minimized and allows us to select part objects. Select the entire 3D solid and then right-click or press Enter to accept the selection. The dialog reappears and lists the selected surfaces under the Selected Machining Features. Now pick Save. The part is now defined and listed under the Machining Job in the Machining browser. Now switch to the top view. You can see the actual 2D profile that was created to use in toolpath computations. In this step, we'll define the raw stock from which to cut the part. First, switch back to the ISO view. Now, from the Program tab, select Stock, and then select Cylinder Stock from the menu to display the dialog. Under Outer Dimensions, set Radius R to 1.5 and length L to 3.25. Pick OK and notice that the stock type now appears under Machining Job in the Machining browser. If the stock does not display on the screen, select the Stock Visibility icon located at the base of the Machining browser. Once the stock model is created, you can move it in alignment with the part if needed. From the Program tab, select Align. For Z alignment, select Right and then pick OK. The stock is now aligned to the right side face of the part geometry in the Z-axis of the lathe. Next, we'll set the material for the stock geometry. From the Program tab, select Material to display the dialog. For material, select Aluminum-6061 from the list of available materials and then pick OK. If the material texture does not display on the stock, select the Material Texture Visibility icon located at the base of the Machining browser. Now, let's discuss the machining setup. The Setup icon displayed in the job tree defines the Turn Machine Coordinate System, or MCS, and is defined automatically. CNC turning centers, or lathes, use the Cartesian Coordinate System for programmed coordinates. They follow the convention that the spindle axis of rotation is designated as the Z-axis. Secondly, The axis perpendicular to this axis, along which the tool travels to cut into the stock, is designated as the x-axis. So, the part and spindle rotate about the z-axis, and moving the tool along the z-axis provides the direction of feed, and moving it along the x-axis provides the depth of cut. By default, in the turn module, the lathe z-axis is aligned with the world x-axis, and the lathe x-axis is aligned with the world y-axis. The lathe y-axis points in the same direction of the world z-axis. The MCS is displayed as a triad with a blue z-axis, a red x-axis, and a green y-axis. The World Coordinate System, or WCS, is displayed the same way, but with XYZ coordinates labeled on top of it. While the setup coordinate system is defined automatically, we do have to define the work 0, also referred to as the workpiece origin. This location defines the 0 point from which all toolpath points are interpreted by the controller. Typically, this is set to the rightmost face of the part or stock geometry on the lathe z-axis. From the Program tab, select Work 0 to display the dialog. Select Set to Stock Box and set the 0 face to rightmost. This locates the machine origin point to the rightmost face of the stock geometry along the lathe z-axis. Now pick Generate and notice that the MCS is translated and that the work 0 now appears under Setup 1 in the machining browser. Now we need a turn tool to turn the part. From the Tools tab in the Machining Objects browser, select Create Edit Turn Tools to display the dialog. Select the Diamond Insert tool icon and we'll set the following parameters in the dialog. We'll set Name as Diamond Insert-OD. Inscribe Circle Radius to 0.5. Tip Radius to 0.02. Tip Angle to 55. Relief Angle to 20. Orientation to OD forward. Next, we'll switch to the Feeds and Speeds tab and use the following values. For spindle parameters, we'll set Speed to 300 RPM, Max Speed to 350 RPM. For feed rates, we'll select IPM and then set Plunge to 5, Approach to 7.5, Engage to 7.5, Cut to 10.0, Retract to 15, Departure to 15, Transfer to User Rapid. Now we'll pick Save as New Tool. Note that you can edit the tool parameters and pick Save Edits to Tool to save the changes. You can also create additional tools by assigning a different name and specify new tool parameters. Okay, the tool is created and listed under the Tools in Session on the left, and we'll pick OK to close the dialog. Notice that the new tool is also listed under the Tools tab of the Machining Objects browser. Now we're ready to create our turn roughing operation for machining the part. From the Program tab, select Turning and then Roughing from the menu of operations. This will display the Turn Roughing Operation dialog. From the Tool tab, we'll select the Diamond Insert OD tool we just created as the active tool. Note that the tool parameters of the currently active tool are always displayed in the status bar at the bottom of the Machining Objects browser as shown here. Next, we'll pick the Feeds and Speeds tab. Then we'll pick the Load From Tool button. The system will now retrieve the feeds and speed parameters that we set when the tool was created and associate them with the current operation. Next, we'll select the Clearance Geometry tab. Here, we'll set the clearance settings to automatic and cut transfer to clearance plane. In the automatic mode, the system will determine a safe height for locating the clearance plane. Setting cut transfer to clearance plane will force all transfer moves to be performed in this computed clearance plane. When this dialog is active, the clearance plane is shown on the graphic screen. Now, switch to the Global Parameters tab to specify parameters for controlling the cutting. Here, we'll set the approach type to outer diameter. We'll set stock to 0.01. This means that we'll be leaving a 0.01 inch thickness on the part after machining. Next, we'll select the Turn Roughing tab and set the following parameters. We'll set Cut Pattern Type to Linear Cuts. This will create a cut pattern with straight line cuts. Offset cuts, on the other hand, will create cuts that are successive offsets of the turn profile. Now we'll set cut direction to positive. This will ensure that the cut traverses along the positive z-axis of the lathe coordinate system. We'll uncheck Final Cleanup Pass and we'll set depth per cut to 0.0625. Note that the depth per cut is always set to an absolute value. Now we'll switch to the Entry-Exit tab. Entry-Exit parameters control how the cutter will engage material as it begins cutting, and how it will leave the material as it completes cutting. Under the Entry tab, we'll set the approach motion length to 0.025. Then we'll set the engage motion length to 0.025 also. Next, we'll switch to the Exit tab and set the retract motion length to 0.025, and then do the same for the depart motion length. Now pick Generate. The Turn Roughing toolpath is generated and the operation is listed under Setup 1 in the machining browser. Now switch to the top view and see that the toolpath is also displayed in the graphic screen. Note that the display of the toolpath in the graphic screen can be turned on and off by selecting the Toolpath Visibility icon located at the base of the machining browser. The new toolpath can now be simulated to display the in-process stock model. We'll switch to the Simulate tab at the top of the machining browser. From the View toolbar on the left, select the ISO View 1 icon. Select Preferences under the Simulate tab and set the simulation display mode to 3/4 and click OK. Under Preferences, uncheck Simulate by Moves and then adjust the slider to set the simulation speed. Now, select the turn roughing operation and then select Play. Additional simulation controls are available on the menu, such as step, pause, etc. Selecting ISO View 1 or ISO View 2 from the View toolbar orients the view suitable for viewing turned simulations. Once the simulation is complete, the state of the stock model is displayed on the graphic screen. To view the cut model with textures applied, select the Material Texture Visibility icon located at the base of the machining browser. Now, we'll turn our attention to finishing the outer diameter of the part. We'll use the same tool, but this time use a finishing operation. Switch to the Program tab in the machining browser. Select Turning and then Finishing from the menu. From the Tool tab in the Turn Finishing dialog, select the Diamond Insert OD tool. Now, pick the Feeds and Speeds tab and select the Load from Tool button. The system will retrieve the feeds and speeds parameters that was set when the tool was defined and associate them with the current operation. Pick the Clearance Geometry tab and set the clearance plane definition to Automatic and Cut Transfer Method to Clearance Plane. Now we'll switch to the Global Parameters tab to specify parameters to control the cutting. Set the Approach Type to Outer Diameter and Stock to 0. We will not be leaving any thickness on the part after machining, effectively removing all stock left over from the previous roughing operation. Now, under Cut Containment, check the box for Select Start and End Points. This allows you to specify an area to contain the toolpath by selecting Cut Start and Endpoints. This is useful in cases where only a section of the part needs to be machined. In this tutorial, we will graphically select the start and endpoints from the part to specify the cut containment. Click on the Pick button. This minimizes the dialog and prompts you to select Start and Endpoints. From the View toolbar, we'll switch to the top view. Now, with the End Snap toggle on, we'll select a point on each end of the part. The Turn Finishing dialog reappears and displays start and end coordinate values for the cut containment. Leaving all other parameters with default values, we'll pick Generate. The operation is generated and listed under the operations tree in the machining browser. Now, to verify the toolpath, we make sure it's selected in the operations tree. Select the Simulate tab, select ISO View 1, and then pick Play. Now, with the toolpaths complete, we're ready to post-process to an output text file containing G-codes that can then be sent to the machine tool to actually machine the part. Select Setup 1 from the machining browser. Right-click and then select Post. This will post-process all operations created under the setup. Use the Post and Save As dialog to specify an output file name and location for the post-process G-code file. By default, the part file name and the setup name are appended for the G-code file name. Also by default, the posted G-code file will be saved to the folder where the part file is located. Now pick Post, and the G-code file is displayed in Notepad, where it can be viewed or edited manually. Now close Notepad. At any time, you can create an informational report of your machining operations. Right-click and select Information to display and print the report. This dialog provides an estimate of the machining time required for the operations in the setup. You can perform the same right-click sequence on the machining job to determine the estimated machining time for all setups. Pick OK to close the information dialog. You can also create a setup sheet by generating a shop document. This is typically used to instruct the machine operators on how to set up and machine the part on the CNC machine. Switch to the Program tab, select Setup 1, right-click, and then select Shop Documentation. Select Template 1 and then click Save. This creates an HTML-based shop documentation that can be viewed in a web browser. You can perform the same right-click sequence on the machining job to generate shop documentation for all setups. This completes the VisualCAM-TURN module Quick Start tutorial. For further assistance, you can visit the online help supplied with the program or visit www.mexsoft.com for additional tutorials. Thank you.